Okay, so now we're going to do an example of calculating arc length of curve. Okay, so the first thing you have to understand is what kind of curve you're looking at. Again, you don't have to necessarily trace it out to get the correct answer. Okay, if you understand what's going on. So this is a cardioid. Okay, so the one thing to realize is that to trace this out, right, we don't want to calculate the arc length to be too much, because just like area, we don't want to go, we don't want to double count things in a manner of speaking. Okay, so if we only want to trace out one path around this thing, right? So the thing to notice about this is that if we go from 0 to 2 pi, one revolution around the circle, okay, what happens is we trace out this cardioid one time. That means that if we integrate this from 0 to 2 pi, we will get the full arc length of the curve. Now, in some cases, for example, in a circle, okay, so if I have if I have r equals 4 cosine theta, if I go 0 to 2 pi on this thing, I'm going to end up tracing this circle twice. Okay, I don't want to do that. So in this case, I wouldn't go from 0 to 2 pi to trace this thing. I would trace it from 0 to pi, because from 0 to pi gives me one trace of the figure, of the graph. Okay, so keep that in mind when you're working on these. How many times am I tracing this thing as I go from 0 to 2 pi, as I go one revolution around the unit circle? Okay, keep that in mind. Okay, so now that I know that, I know I'm going to integrate from 0 to 2 pi to get the arc length of this figure, of this cardioid. Okay, so L equals the integral from 0 to 2 pi of what? The square root of r squared plus dr d theta squared, d theta. Okay, so now let's plug it in. So 0 to 2 pi, and r, well, that's going to be what? It's going to be the square root of 2 plus 2 cosine theta squared plus the derivative squared. Well, what's the derivative of r with respect to theta? Well, this is going to be 0. This is going to be what? It's going to be negative 2 sine theta. So this is going to be negative 2 sine theta squared d theta. Okay, so all I did was used r and the derivative of r. Okay, so now let's simplify this. Okay, so now, next, we're going to simplify. So this is going to become, okay, what? 4 plus 8 cosine theta plus 4 cosine squared theta, and then this piece is going to become plus 4 sine squared theta d theta, right? Okay, now, what am I going to do now? Well, looky here. I've got a 4 and a 4. So I can cancel this out. Look at this. I got a 6. So you always want to look for things that simplify out. If you see the Pythagorean identity and you can factor something out, use it. So here it is right here. So now I'm going to factor out the 4. Okay, and so I get, actually I could factor out I can factor out a 4 on the whole thing. Why not do that? Yeah, I can factor out a 4. Let's do that. 4. And I'm going to have 1 plus 2 cosine theta plus cosine squared theta plus sine squared theta d theta, right? So now now again, I've got my 1, right? So this here, I can group and make that 1. That's no problem. And so now what do I get? I get the integral from 0 to 2 pi of what? Well, the square root of 4, I can split this up into the product of 2 square roots. So the square root of 4 is just 2, right? So let me pull that out. That's just going to give me 2. And so I'm going to get the square root of what? It's going to be 1 plus 2 cosine theta. Oh, this is awesome. Plus 1. Oh, look at that. Oh, this is going to be nice. Doesn't always work out this way, but in this case it's going to be nice. So now, this is going to be 2 from 0 to 2 pi, integral of 0 to 2 pi. And this is going to give me what? This is going to be the square root of what? 2 plus 2 cosine theta d theta. Well, guess what that is? 2 plus 2 cosine theta, it's r. Interesting. Okay. But I don't want to do that because we're going to integrate this with respect to theta, so I don't need r, but it's interesting to point that out. Okay, so now using the identity, we're going to use the identity here. Okay, and the identity that we're going to use is this one. Let me write it up here. So we've seen this one before. So it's going to be cosine squared theta equals 1/2 1 plus cosine 2 theta, right? So that's the identity we've been using. So we're going to use it, but we're going to solve it differently. Okay? Okay. So what we're going to do is we're going to solve for this one. Okay? So the other identity, which is exactly the same as this one, it's going to be cosine 2 theta, and all I'm going to do is multiply both sides by 2 and then subtract 1, and so I'm going to get 2 cosine squared theta minus 1. So it's the same identity, but written differently. Okay? Now, what am I going to do? Well, in this case here, if I add 1 to both sides and multiply by 2, right? So what happens here? So I've got this, and I want to make this, well, hold on a second. No, I've got this, right? And I've got here, right? Okay. So what happens if I add 1 to both sides and multiply by 2 to make it look like this here? Well, let's do that. So if I add 1 to both sides, I get cosine 2 theta plus 1. So I'm kind of like going backwards. Equals 2 cosine squared theta, right? Because minus 1 plus 1 gives me 0. And so now what I'm going to do is I'm going to multiply everything by 2, right? So that means if I do that, I get what? 2 cosine 2 theta times 2, or plus 2 rather, equals 4 cosine squared theta. Okay, so now you might be thinking, well, Mr. C, I got 2 theta here, and I'm dealing with 1 theta, so this is 2 plus 2 cosine theta. You've got 2 cosine 2 theta plus 2. That's okay. We can still make it work, okay? Because just because we have theta, how would that affect? Well, it just means that this is half of this. So what I'm going to do is I'm going to replace this, right, with what? I'm just going to cut the angle in half. Right? So let's do that. So now what I'm going to do, where am I at? Okay, so I'm down here. So let's erase this. Okay, and so now I have L equals what? It's going to be 2 times the integral from 0 to 2 pi. Now I'm going to replace this because what I'm saying is since this is true, then what does this mean? That means 2 cosine theta plus 2 is equal to 4 cosine squared theta over 2, right? Makes sense to me. Okay, so that's what we're going to do. So now what do we get? We get this. 4 cosine squared theta over 2 d theta. And that's exactly why we're doing that. If you're wondering why we were doing this, it's because we need the square. We need to get rid of this radical. It makes things a lot easier to integrate. Okay? Because once we get rid of the radical, then it's just a cosine, and we can integrate that easily. So now this becomes what? Now I've got a 4 here, so I'm going to split this off. I get another 2, so this is going to be 2 times 2, so this is going to be 4 times the integral from 0 to 2 pi of the square root of cosine squared of theta over 2. So that's just going to give me cosine of theta over 2 d theta. And look at that. Now I can integrate this all day long. Okay? Now, hold on a second here. Okay, so now, what else? Oh, gotta have absolute value, because remember, cosine can go from -1 to +1. So again, when we take the absolute value, or excuse me, not absolute value, when we're taking the square root, okay, we want to make sure that we put the absolute value signs in there. Now, because again, now does this go? Yeah, we're going from 0 to 2 pi. Oh. Yeah, we're going 0 to 2 pi, so we have to think, okay, is this thing going to go to negative? So it will. Because from 0 to 2 pi, this thing is going to go from negative 1, or positive 1 to negative 1. Okay? Because this is going to go from 0, this angle in here is going to go from 0 to pi. And 0, it's going to be 1. At pi, it's going to be negative 1. Okay? But there's a way we can fix that. Okay? We can restrict the interval. Okay? Because this is symmetric. Okay, so remember, this is a cardioid, right? And so we know that this is symmetric with respect to the polar axis. So that means that we can go ahead and just do this from 0 to pi and double it, right? So let's do that. So I'm going to rewrite this as, I'm going to double this, so I'm going to double the area, so I'm going to double this, so this is going to make it 8. And now instead of going from 0 to 2 pi, I'm just going to go from 0 to pi, and that gets rid of the absolute value signs because it's always going to be positive. So good, now I can do cosine of theta over 2 d theta, and now we can go ahead and integrate. Okay? And so now the antiderivative of cosine is sine. So this is going to be 8 times, now here's, again, you have to be careful because we have to divide by the derivative of the inside function. So the derivative of the inside function is a half, so we have to divide by half, or in other words, multiply by 2. So this is going to be 2 times the sine of theta over 2, which is evaluated from 0 to pi now. Okay, so now guess what? This is easy because this comes out, this becomes 16, and look at this. At 0, this is going to be the sine of 0, which is 0. At pi, this is going to be pi over 2, or the sine of 90 degrees, which is going to be 1. So this is just going to be 1 minus 0, which just equals 16, and that is the answer. Take care. Have a great day.